Everybody, good morning. Today, I want to teach the kids to learn how to solve proof type of math problems. You know, in the US math education, this is a really weak spot. A lot of times in the school, even in a lot of math competition, they only ask students to calculate the numbers. They did not ask students to prove something. So, but actually this one is a very important math skills you need mask. You know, I remember when in the college to learn math, in math department courses, most time our job is to prove, not to calculate numbers, to prove or disprove. So, you know, as even you as a mathematician, most of work is prove and disprove. So now that's the reason I want to open this section, pick a lot of classic examples in math, proof problems. I remember the most famous one is to prove root 2 is an irrational number. Irrational number. So what is an irrational number? To explain this, now let's first start from integers. Integers, the set of integers in math, we use capital N to represent. This represents integers, okay, such as 0, -1, +1, +2, blah, blah, blah. All these kind of numbers we call integers. Integers include the positive integers, negative integer, and 0. Then later we learned rational numbers or fractions. So rational numbers in math, we use capital Q to represent all the rational numbers. This is called rational numbers. Rational numbers. Rational numbers, the general form is you can write P over Q. And P, Q belong to integers. And Q is not equals 0. If Q equals 0, make denominator 0, this fraction is meaningless, right? So this kind of number we called rational numbers, okay? Then later we learn the real numbers. In math, we use capital R to represent real numbers. Real numbers, that's rational numbers plus all irrational numbers. So what is irrational numbers? Irrational numbers, that means you cannot write this kind of fraction form. All the numbers I use capital Q bar. So this kind of numbers like pi, root 2, e, right? all these numbers, this kind of numbers are irrational numbers. Okay. Then later, you learn the complex number. Complex number, that's real numbers plus all the imaginary numbers, right? So irrational numbers, suppose I use I to represent. So for complex number, the general form is A plus I times B. So here, A and B are all real numbers, okay? So this is a number set in math. Usually you learn this integers, rational numbers, this irrational numbers, real numbers, complex numbers, okay? Now, let's go back to our topic to prove root 2 is not a irrational number. So to prove that, the easy way is use a contradiction. So, this one also is not, is a very weak spot in math education, US math education. So usually when you try to prove something, the straightforward thinking is just prove that's right? And actually the shortcut, a lot of times, you do this way, it's hard. But if you prove if this result is not true, the contradiction things will happen. That will be much easier. This kind of way we call it contradiction. Now let's see. We try to prove root 2 is not a rational number, right? It's not a rational number. So if we use contradiction approach, we can set suppose root 2 is a rational number. Then now let's see what is a contradiction will happen. Let's say root 2 is a rational number. If root 2 is a rational number, based on the definition of rational number, that means root 2, it means root 2 can write as P over Q, and P and Q belong to real numbers. Q is not equal 0. Also, the greatest common factor, GCF, between P and Q, this one equals 1. So that means P and Q are relative prime, okay? So if this one happen, now let's say both sides are square. You got 2 equals P square over Q square. So then we can write this one is P square equals 2 times Q square. So then you consider P square, it's a number, and Q square is another number. Then this one tells us P square it's an even number, right? P square it's an even number. Okay. Then from this we can get P should be an even number too. So that means we can write P is 2 times another integer. Suppose that's m. M is an integer, right? Then you can do this way. You can say, write P equals 2m over q. So then both sides square, then we can get 2 right here. Both sides square get 2 equals 4m squared over q squared. So from this, we can get a q squared equals 2m squared. So then from this, we can get q. You know, q squared is a number, m squared is another number. So from this equation, we can get the q, it's even number 2, right? Because q squared is an even number. So q should be an even number 2. So now let's say q equals 2 times n. Then n is an integer. So now we can get, so now from here we can get P and Q, their greatest common factor equals, say, greatest common factor between 2m and 2n. So that means this one equals 2, right? At least equals 2, right? Times greatest common factor of m and n. Greatest common factor m and n, at least that's 1, right? So then this equals 2 is not equals 1. So then that means P and Q has a common factor bigger than 1. That's contradiction with our condition here, right? So then we got a contradiction. Therefore, this is a contradiction. Therefore, root 2 has to be a irrational number, right? Has to be a irrational number, right? So then we finish our proof of root 2 is not irrational number. So we finish this video. Thank you. We can show, if you're interested, please subscribe it. Then I'll show you more this classic proof problems in the next video. Thank you. Bye.